In this question it is given that three very large plate of same area are kept parallel and close to each other. They are considered as ideal black surfaces and have a very high thermal conductivity. The first and third plates are maintained at a temperature of 2T and 3T respectively. The temperature of middle plate under steady state condition is. So first of all, just try to understand this question. Over here they are given that very large plate of same area. So we are considering three such plates. Let's say plate 1, plate 2, and another one we can take it as plate 3. And the area of each and every plate is same. Let's say area of each plate is equal to nothing but A. And they are considered as ideal black surfaces. So the value of E we can take it as 1 and have a very high thermal conductivity. The first and the very high thermal conductivity means even if there is some loss of temperature, that is going to uniformly distributed on the surface. No need to take it as the temperature of different parts are different, temperature of each and every part is same. The first and the third plates are maintained at a temperature of 2T and 3T respectively. So the temperature of this we can take it as something but 2T and temperature of this we can take it as something but 3T respectively. The temperature of middle plate under the steady state condition is. So steady state condition means we can say that the like it is in thermal equilibrium with the surrounding. That means the amount of heat energy absorbed will be equal to the amount of energy which is released. So assume that the temperature of this object is equal to something like T dash. Now we can observe what about the value of amount of energy emitted by this object. So this is going to emit some radiations and in each and every possible direction. So this is also going to emit some radiations from the upper surface, and this object is also going to emit some radiations from the upper surface and some amount of radiations from lower surface, and this is also going to emit some radiations in the from the upper surface as well as from the lower surfaces. Now we can observe that this energy which is emitted by the lower surface of first plate and the upper surface of last plate are going to absorb by this object. So we can write the amount of energy absorbed by this object. So the amount of energy absorbed by this object, dq divided by dt, will be equal to the amount of energy which is emitted by the first plate and third plate. So we can write that will be equal to E sigma A into temperature of third plate, first plate we can take it as something but 2T. So this we can take it as 2T raised to 4 plus the amount of energy which is emitted by the third plate, that is equal to E sigma A temperature of third plate, that is 3T raised to 4, and this should be equal to the amount of energy which is emitted. So this much amount of energy is absorbed is equal to the amount of energy emitted by the second plate, and the energy is going to emitted from both the surfaces, from the upper surface as well as from the lower surface. So we can write as E sigma A into temperature of object, that is T dash raised to 4, and such two surfaces are there, the upper surface as well as lower surface. So total surface area we need to take it as something but 2A. Now as it is in thermal equilibrium, we can say that dq by dt absorbed should be equal to dq by dt emitted. So we can write this as E sigma A into temperature of this T raised to 4, and if you are going for 2 raised to 4, we'll get the answer as something but 16, and this 3 raised to 4, which is 81, is equal to the amount of energy which is emitted by this object, that is E sigma into 2 times of A into T dash raised to 4. So we can cancel the common terms like E sigma and A, and here also E sigma and A. So we can write this T dash raised to 4. So that is on the left side we'll get as it is 16 plus 81, which we can take it as 97 divided by 2 on right side, left side we can write on right side. So into T raised to 4 will be equal to T dash raised to 4. Our aim is to find out the value of T dash, so we can go for raised to 1 by 4 on both the side. So on right side we'll get as nothing but T dash, on left side we'll get as it is 97 divided by 2 raised to 1 by 4 into T. So this will be the temperature of that second plate.